Hi, I'm Philip with Real Python, and thanks for joining me today on this very special Python Basics exercise course, where you'll practice working with functions and loops. Our exercises courses are all about training. You'll train the process of writing code by solving carefully selected exercises. You'll also train reading over other people's code and communicating your thought process. Doing all that, you'll practice the concepts that you've learned about in an associated course or tutorial and help make them stick. In the upcoming lessons, I'll introduce you to tasks, give you an opportunity to solve them yourself, and then show you step by step how I solved each of them. You'll go through 3 steps for each task. Learn about the exercise, code your own solution, and then you'll compare your solution with mine. When I walk you through a task, I'll explain what I do and also why I do it like that. That will give you a chance to compare not just our final solution, but also how we got there. You will start with solving some review exercises in the first section, and then you build up towards a proper challenge. Then you'll do more review exercises and another challenge. A little bit like you're trapped in a loop. But luckily, this loop isn't infinite. And after you solve the challenge, I'll send you off with some additional resources. But before we move on, let's have a quick look back. Before starting this course, you should have watched the Python Basics course on functions and loops. If you went through that course, you're well equipped to solve the tasks that I'll throw at you. The concepts that you'll practice in this course are defining a function, asking for user input, do basic arithmetic, run for loops, and if you're somewhat familiar with these concepts and you want to strengthen your knowledge with some practical programming tasks, then this course is exactly right for you. Before you get started, there's another tiny bit of background for this course, which is that I'll use IDLE, the integrated development and learning environment that comes bundled with Python. If you've gone through the Python Basics courses, then you're already familiar with the tool. If not, then you can check out these associated courses that cover getting started with IDLE. If you're just here to train and you're familiar with other code editors, then feel free to use whatever tool you like to solve the upcoming coding tasks. And that's all there is to say to get you set up. If you're ready to get started and do some hands-on programming, then see you in the next lesson, and there I'll introduce you to the first exercise to get you warmed up. Let's get started with the first exercise. I will read the exercise out for you, and then you can pause this course, solve the exercise yourself, and then go on to the next lesson where you can see how I solve the exercise. Your first exercise is to greet someone. Write a function called greet that takes one string parameter called name and displays the text hello, comma, and then the name, exclamation mark, where the name is replaced by the value of the name parameter. For example, when you pass in Lyra into the greet function, then the function should display hello Lyra. Okay, now you can pause this video course, and once you're ready, head on to the next lesson where you can see how I solve the exercise. Welcome to the first exercise. It's a good idea to post the exercise again as a comment so that you know what you need to work on. Since I have a big font size here, I divide the exercise into different lines. Later in this course, it will also make sense to have it in different lines because it's kind of like a to-do list that you're working with here. But this exercise is quite straightforward, so you can see this as one bigger task. You need to create a function, def greet, and then in the next line, you print hello. And for now, let's skip the name. Let's just print hello and see if that works. To run the file with idle, you need to save it. So here, let's use greeter.py. And when you run the module, you can call greet. And the output is hello. Okay, so that works. Now you need to pass in the parameter name. So inside the parentheses of the greet function definition, you add name. And then you go to the print function call, and then you add curly braces with the name variable to the string. If you run the module now and you call greet with the name Sadie, for example, as a string, then you see it doesn't print quite correctly. Can you spot why? Yeah, I forgot the F at the beginning of the string to make it an F string. Only then the string formats with the variable that you pass in. And also the exclamation mark belongs to the end. Let's try it again. If you run greet and then pass in the string Sadie, then it prints hello Sadie. Perfect. That means the exercise is solved. And you can remove the comment at the beginning of this file, so you only have the greet function there. Perfect. Let's move on to the next exercise. This one is called cube. And I want you to write a function called cube that takes one number parameter and returns the value of that number raised to the third power. Test the function by calling your cube function on a few different numbers and displaying the results. Again, you can pause this video course and then continue once you've solved the exercise to see how I solve it. I already pasted and formatted the exercise task. It says, write a function called cube that takes one number parameter and returns the value of that number raised to the third power. Test the function by calling your cube and displaying the results. Okay, so there are basically two tasks that I want to divide. So I will write my function in between those two parts. The first part is write the function and then test the function underneath. The function name is cube, so it's def cube, opening parentheses, closing parentheses. And the cube function takes one parameter, which is a number. I call this variable num. And then in the next line, indented, return num. Well, actually, let's just return num for now. Run the module to test if the function call works and the number is returned without doing anything to it yet. So if you call cube with the argument 3, then the idle shell returns 3 because you don't do anything with the number yet, but it's cool to test this. So what do you need to do if you want the third power of the number? What you could do is write num multiplied by num multiplied by num. So in our example, this would be 3 times 3 times 3. That would actually work. So let's try it out. If you call cube with 3, then the result is 27, which is 3 raised to the third power. But that doesn't look very nice. So there is another way you can do that, and that's using the double asterisk. So if you adjust the return statement to num asterisk asterisk 3, you raise the num to the third power. Try it out in the shell. If it still works, if you pass in 3, it's 27. And that's correct. Cool. So that's the first part of the exercise. You have created a function that takes a parameter named num and returns that number raised to the third power. Okay, let's tackle the next task of this exercise. Test the function by calling your cube and displaying the results. Basically, it's what you did in the idle shell, you do in the scripting window now. You call cube. Let's do it with 1, and we expect 1. And then call it with 2. So cube, opening parentheses 2, closing parentheses, and you expect 16. And after that, let's call cube with the argument 3, which should be 27. All right, save the file and run the module. Nothing happens because you need a print function to actually show something in the output. So go to line 7 where you have the first cube call and add print, parentheses, then cube1, and then in the end, closing parentheses. And the same in the next two lines, print, cube2, and in the last line, print, and then inside the print call, the cube call with the 3 and the closing parentheses at the end. Now, if you save and run the module, then you should see the expected numbers, which is, well, 1, 8, and 27. So apparently I didn't do the right math there. So it's not 16, but 8, because 2 raised by the third power is 8, not 16. Yeah. that's a good sign that our cube function works correctly. And sometimes it's better to have functions than just to rely on your own math skills. But yeah, with all of this done, you have tackled the second part of the exercise. But I want to show you something else before we wrap up this lesson. Instead of returning num and then the 2 asterisks with the 3, you can use the built-in function POW, which takes a base, which is your num variable, and the exponent, which is 3 in this case. And then when you run the module, you see the result is the same. So this would be an alternative solution. Now with the 2 exercises solved, let's have a challenge. This one is called Convert Temperatures. Write a program called temperature.py that defines 2 functions. Convert cell to var, which takes one float parameter representing degrees Celsius and returns a float representing the same temperature in degrees Fahrenheit, using the following formula. Uppercase F equals uppercase C multiplied by 9 divided by 5 plus 32. You will find this formula also in the text below this video. The second part of this challenge is to create a function convert var to cell, which takes one float parameter representing degrees Fahrenheit and returns a float representing the same temperature in degrees Celsius, using the following formula: uppercase C equals parentheses uppercase F minus 32 closing parentheses multiplied by 5 divided by 9. So one function that converts Celsius temperatures to Fahrenheit, and the other function converts Fahrenheit to Celsius. But this is a challenge, so it doesn't stop there. The program should also prompt the user to enter a temperature in degrees Fahrenheit and then display the temperature converted to Celsius. Then the program should prompt the user to enter a temperature in degrees Celsius and then display the temperature converted to Fahrenheit. Third, it should display all converted temperatures rounded to 2 decimal places. At the end of this challenge, you should have a Python file named temperature.py, and when you execute it in the terminal, there should be a prompt asking the user to enter a temperature in Fahrenheit and then output the converted Celsius temperature. And after that, prompt the user to enter a Celsius temperature and output the Fahrenheit to the terminal. And when you output those temperatures in the terminal, you should round them to 2 decimal places. Because remember, the numbers should be floats, so there might be a bunch of decimal places behind the dot, but you should round it to 2. So yeah, there's quite a bit to do, but it's a challenge. So stop this video course, take your time and tackle the challenge. And once you solve the challenge yourself, you can come back to this video course and see how I solved the challenge. Ooh la la, there are a few things to do in this challenge, but let's tackle it by dividing the big challenge into smaller tasks. Start by creating a new file named temperature.py, because that's the first thing we need to do, write a program called temperature.py. Once you have saved it, you can add the file name on the top of your Python file. At least I do it so you know exactly in which file you continue to work. Yeah, that's a small step, but it's okay to start with small steps to not overwork us at the beginning. Next, start creating the convert cell to var function. Convert cell to var takes one argument that you need to define as a parameter, and this one is the Celsius temperature that you want to convert. Name this variable temp_cell. And then for the formula of temp var in the next line in the function body, you can use the formula that is stated in the challenge text, which is C multiplied by 9 divided by 5 plus 32. And the C in this case is the temp cell variable. So here now you can be very strict with Python formatting and put a space between the slash of 9 divided by 5, or even put parentheses surrounding it. For the calculation, it doesn't matter. So here it's more stylistic if you find it a bit better to read than how it was in the challenge text. And then in the function, you need to return the temp var variable. Once you save and run the module, and then call the convert cell to var with the value 37, and then you should get the Fahrenheit temperature. And this one looks a bit weird. It is correct. It's 98.6, but there are a bunch of zeros and a 1. Let's investigate our calculation, what is going on there, and why those zeros are appearing. Remember that I said just a few moments ago that the parentheses are purely aesthetical? Apparently, they are not just purely aesthetical, but it also defines in which order Python calculates the values. And depending on the calculation, the conversion of integers to floats gives a result that is not entirely representable in the other format. Let me be a bit more specific here. When you divide two integers in Python, the result can be a floating point number. The representation of this number can sometimes include many zeros after this decimal point due to how floating point arithmetic works in computers. Because computers use the binary system, which is a base 2 system, to represent numbers, while we humans, and I assume you are a human watching this, typically use the decimal, which is a base 10 system. So when converting numbers between those two systems, some numbers that are easily represented in decimal can not be precisely represented in binary. As a result, the binary representation can sometimes be an approximation. And that's why you see the bunch of zeros and the 1 in this result, depending on if you put the parentheses in there or not. If you want to learn more about the floating point number representation, check out the Python Basics course on numbers and math, where Bartosz explains this topic way better than I did right now. Now, the cool thing in programming and here working in idle is that you can actually try it out, how it behaves differently when you remove the parentheses. So if you take away the parentheses and make exactly the same function call with 37, then you get 98.6. Without the zeros and the 1, because the order how Python executes this formula is different. And again, you can try this out here in the idle shell. So let's dissect this formula in the shell and recreate it bit by bit. First, we pass in the 37, and then it's multiplied by 9, which is 333. Then you divide it by 5, which is 66.6. So here, this conversion works without this approximation. And then you add the 32 to the 66.6. So this gives this clean 98.6 number. However, if you multiply the 37 by 9 divided by 5, that's when you put it into parentheses, then you get 66.6 and a bunch of zeros and a 1. So here it doesn't entirely work. So let's see what 9 divided by 5 is, which is 1.8. And apparently this one here is the culprit. Because when you multiply 37 by 1.8, then the conversion isn't clean anymore and Python needs to do an approximation, and this results in the 66.6 with a bunch of zeros and the 1. So if you would add the 32 here, then it would be the 98.6 with a bunch of zeros and a 1. So although it's not exactly the same, you can choose whichever format. Because if you remember, you should round the number anyway to 2 digits after the dot. So you don't need to care that much about this approximation here. And I like the look with the parentheses more, so I will add the parentheses again and continue with this formula in the next lesson. The second part of the challenge is very similar to the first one, only the other way around. So this time the function is convert var to cell with a parameter named temp var, because you need the Fahrenheit temperature as an argument when you call the function. And then again, you can take the formula from above, but this time the parentheses is super duper important because you need to subtract the 32 from the temp_var variable first before you multiply by 5 divided by 9 because of this arithmetic rules of which comes first. Otherwise, you would multiply the 32 with 5 divided by 9, and you don't want this. So first you need to subtract the 32 from temp_var, and then again, you can decide if you want to put a parentheses around 5 divided by 9 in the end, and if you want to put a space in there so the slash stands alone. And in the end, you return temp cell. The function looks a bit different. Only the formula inside is a different one. And when you call convert_var to cell with the argument 72, then the function returns 22.222222 and so on. So there is a similar situation like before. There are a bunch of integers after the dot, but the rounding will be tackled in one of the next lessons. But now that you got the convert_var to cell function, you can actually check the 98.6 from before. Perfect. It converts to 37 Celsius. So the function works as expected.